Hmm. All right. We are back. Oh, nice. How is everyone doing? Hey folks, let me know when you join so that I know, that I can get started. Okay. I hope you can hear me as well. Live for chat. Ba-ba-ka-dong. Hey folks. Hey folks, if you joined me, like if you're in the stream, let me know that you're there so that I can get started. Otherwise, I think the stream should be working okay. Ah, look, I'm live. Hello. Is anyone there? Maybe people are still working. Hey folks, if you're there, just, send me a message so that I know I'm not alone here. Hey Philippe. Ha! Thanks for dropping by. How you doing? How's Portugal? I heard you have a lot of fires over there. Hi. Oh, that's sorry. How do I pronounce your name? Semislaw? Semislaw? I'm at the top right corner. Yeah. That's true. How's Portugal? I heard there are a lot of fires ongoing, unfortunately. I hope you're safe down there in Lisbon. It's mostly around Aveiro, right? So yeah, I mean we can get this party started. Just to give you a little summary of what we've done so far. So basically, this live stream is all about coding Elixir live and oh, Shemek. Okay, I will call you Shemek. Yeah, it's tricky. Do you have bad air quality there too? Because in Braga and in Porto especially, man, the air quality is just, you shouldn't breathe. Just stop breathing for the day. During the night is okay, but depends on the wind as well. Yeah, so like what we worked on yesterday is a data processing pipeline for posts that come from BlueSky. So we connect to the BlueSky firehose API, and that just sends us a lot of events, through a WebSocket connection that we open here. And unfortunately, we can't filter these events, so they only send us all like retweets, post events. So we also filter them out, but that's later. So we have this as a high level. Actually, let me use Excalibur. So what we have basically is we have BlueSky over here. Man, just go in there. Thank you. BlueSky. And that's the firehose API. And it's not firehose, it's firehose. And then we have our WebSocket here. And that one connects to the to firehose like this. And now what we this is our application here, right? So boom, this is all our application, and BlueSky is outside of it. So what I now want to do, so what we do next actually is we have a buffer, and this one is a ring buffer. It uses a ring buffer library, and the WebSocket, whenever it receives an event, it just puts the event in the buffer here. So that way we can just receive a lot of events. Oh, it's not as bad. Okay, good to hear that. So yeah, in this situation, we receive a lot of events from BlueSky, and we just receive them, we acknowledge them, and then we put them in a ring buffer. And we put the ring buffer to like 10,000 events or something. So we store 10,000 events, and when the buffer is full, so it actually goes to like 10,000, and then it comes to 1 again, then we override the old events. So this way we always keep like 10,000 events in buffer. And what we do then is we use Broadway, and I'm just gonna make this like blue. So Broadway has a producer, and this one is the first process here, and this one fetches from the buffer, and this basically has a demand. It sends a demand event. Jesus. There we go. Yeah, let's just remove this again. So basically it fetches, like 5 events, 10 events, 100 events from the buffer, and it sends that further to the processor. But actually the processor is just a handle message callback over here. So it's not like it's not a struct, it's all inside a single struct. Sorry, module. It's all inside a single module. And this one, what this one does, it here it fetches like this. It receives it, and what this one does, it decodes the event and it filters out events that we want to ignore. So there's some events like likes, for example, or retweets, these kind of events we just want to ignore. We just want to look at the post, like posts, right? So like new posts. So in here we decode the event because it's a CBOR encoded binary. I actually don't know what CBOR is, but there you go. Concise binary object representation. All right. So yeah, that's the binary data serialization format. And so we decode it, we filter it, and then the next thing is we have a batcher here. And this again is also just a handle batch function. I think maybe like arity 3 or so. So this is the next step. And this batcher, it receives batches of right now 25 posts. And what it does is it actually fetches from the BlueSky, well, not from the firehose API. So from the BlueSky API in general. Boop. So boop. This is the general API. From here, it fetches the post. So for every single post, it fetches, well, actually not at once, it has batch fetches. So it can, in batches of 25 posts, it can receive the whole post content. So that's the idea here, that we kind of hydrate our post, so to say, based on the BlueSky API. Now, this is something we implemented yesterday. So we already have all of this in place. It didn't fully work yet. I mean, I think it worked, but our problem here was that our buffer runs dry. So our producer fetches way too many events from the buffer, and then the buffer is empty. And when the buffer is empty, then for whatever reason, Broadway just stops fetching. Like maybe it waits a second or so, but actually it just stops fetching. So actually, yeah, this is our WebSocket connection. It just uses WebSockX to connect to the firehose API. Then we have our buffer over here, and it uses the ring buffer library. And it just has a certain buffer size, and then we can insert and we can get events. And I'm logging the get events request because that is our producer fetching new events. And we retrieve events from the buffer here. All right, so then we have our producer, and that one is a external module. I thought this would also be part of the Broadway pipeline here, but it's not. It's an external module. So this one actually just it's a gen server. When it started, then it registers as a gen stage producer actually. And whenever the handle demand callback is called, let's make this a little bigger. Whenever the handle demand callback is called, then it fetches events from the buffer, and it converts them into Broadway messages. In here we have a no-op acknowledger, so we don't want to acknowledge the event to the outside world. We just receive them from the firehose API, and that's it. So yeah, this way we fetch the events from our buffer, and yeah, that's basically it. So this is the issue here, because the handle demand function is called, and then in here we return the buffer, or we return the events, but they are at a certain point they're just empty. So that's the issue here. All right, so what I actually tried to fix today, or yesterday we looked at this. So there is the allowed messages and the interval option for the producer. And what I wanted to do is I wanted to throttle the producer to only fetch like 5 messages a second. And that way I hope that our buffer would, not be emptied. And the producer can, keep on pulling. So, and also one thing I wanted to do is change the batch size here. Like ideally we would put it to a batch size of 25, because that is the maximum amount of posts we can receive at a certain point. But I don't think we receive that many post events. So I'm just going to put this to a lower batch size so that we more often fetch the post from the BlueSky API. And I started this thing earlier, but it doesn't seem to have an effect. At least, like I tried to start at Broadway, and it said that there are unknown invalid configuration items here. for the producer. Unknown options, allowed messages, interval. Valid options are module, concurrency, transformer, spawn opt. Maybe spawn opt. Hibernate. Yeah. Is this kind of clear to you all, or do you want some more elaboration on this? Just let me know if you have any questions. Just put a question in the text. All good. Thanks, Philippe. Yeah, so this is what I mentioned earlier. So in this situation here, I started the pipeline and it fetched 3 messages from the buffer, so that's good. And afterwards the buffer was empty. And now we don't see any refetches again. We don't see that Broadway actually comes back and asks, you know, give me another 3 events. It's just a little weird in this regard. Let me just, I have one intuition though. Oh. So my intuition here is that we have a mismatch. No. So my intuition here was basically that we have a mismatch between our batch sizes and the number of events we return from our producer. So my idea here was that because we only batch like batches of 10, that, you know, like the Broadway pipeline would start, we fetch 3 events from the producer, means from the buffer. Oh, sorry. So the Broadway pipeline starts, and then we try to retrieve, you know, 10 events, because that is kind of our demand here, maybe. And that's why we do handle demand 10. So we try to refetch 10 events, but our buffer is empty, so return 0. And that means that our batch here never fills up. So our batch, you know, it's still waiting for 10 events, and it might not, you know, retry to refetch another 10. That was my intuition here. That was my thinking. So that might actually be the issue, you know, because now the batcher here is just idling because it doesn't have enough events and it doesn't refetch demand. But I found it interesting. I would expect, you know, the handle demand function to just call until it actually receives whatever it required. So yeah, I wanted to look up that thing in the documentation because the min demand. Yeah, the maximum demand is 10. I mean, does any of you have an idea about this? Like, why? Oh, interesting. So this one here actually means that we need to return either continue or emit to indicate that all batch messages must be emitted or continue batching. Ah, so interesting. What could also happen is that our batcher just doesn't say, well, you know, it receives 0 events, and then it doesn't say, well, I need to continue fetching events. Interesting. Wait, because our callbacks is handle batch. Yeah, this is weird because in here, like the response of handle batch is just an array of messages. Yeah, so that's what I'm returning. All right, got a couple of people on YouTube. Hi, people on YouTube. Why is this batch size message batch size? Oh, well, it's typically an integer, but it can be a tuple of init arg. Ah, hey, you're back. Isn't it like 9 a.m. in Brazil? How are you doing over there? Yeah. Probably you're more like 8:30. Sorry, I started a little earlier. Maybe too early for you. So let me just try this. Let me just put the batch size to 1 and see what happens here. Because I just want to see that we do... Okay, so the handle demand, actually it didn't change. It still expected 10 events, but it only returned 2. And the buffer is empty. That didn't change anything. Man. Let us look into gen stage, because that is where this is defined. Let's see what the documentation says. 9:30. Well, then you're probably having your coffee, so I'm also having mine. Right. So we implemented the handle demand function. This is basically what gets invoked by the Broadway, basically. So Broadway invokes handle demand, and then it expects a... Well, we also get our state back here, and we get the demand, the number of demand. And yeah, so I'm just curious, what happens here? So the producer can do one of these: dispatch exactly as many events as demand. That is not having. That's not what we're doing. Dispatch more events than demand. In this case, gen states will buffer the excess events. These events will be used by the consumer dispatcher next time demand is sent upstream. That's actually pretty cool that it does handle like these overloadings for us. But we don't want that. Dispatch less events than demand. In this case, the producer is responsible for storing the demand, buffering demand, and then emitting events when they are available. Oh, this is our issue here. So we need to... Interesting. So the issue here is that, well, yeah, the producer is actually responsible for storing the demand and emitting events when they're available. So actually our producer needs to, like, you know, schedule itself, so to say, and emit new events like after a second or so. Yeah, interesting. Stopping whenever events are over. No, we don't want that. How do we emit an event? So what we need to do here is basically see, you know, how many messages did we get back? What was the demand? So the demand was 10. We received only 3 messages. So we need to kind of schedule ourselves here, like after 100 milliseconds, or maybe half a second, and try to emit another 5 events, or 7 events, sorry. But how do we do that actually? Do we just execute handle demand again? Well, then emitting events when they're available. See the demand section in the module documentation. Let's have a look there. Demand. All right. Start link. Buffering. Buffering demand. This is what we want. In case consumers send demand and the producer is not yet ready to fulfill this demand, producers must buffer the demand until data arrives. As an example, let's implement a producer that broadcasts messages to consumers. That's what we're doing. For producers, we need to consider two scenarios. What if events arrive and there are no consumers? All right, so then you should buffer. What if consumers send demand and there are not enough events? Yeah, this is our situation. One way to implement such a broadcast is to simply rely on the internal buffer available in GenStage, dispatching events as they arrive, as explained in the previous section. So, notify. Okay, so this is how we dispatch. We just return reply. Interesting. Oh, we can even define a buffer size for these events. That is really interesting. We don't need our ring buffer. We can just rely on GenStage here. So GenStage already offers us buffering, and we can even decide how much, like how many events we want to keep in buffer. That is really interesting. So we can just directly from our WebSocket, we can send events to our producer, and we don't even need to like work with handle demand here. We can just ignore this one. We just emit all these events immediately as they come in. They're gonna be stored in the producer's buffer, and now when the processor comes and asks for 10 events, GenStage will serve it from the GenStage buffer, internal buffer. Interesting. Well, but they also say we should leaving the GenStage internal buffer only for cases where consumers crash without consuming all data. Yeah, so they don't say, I guess we can also just block the handle demand callback until we receive enough value, enough events. I think that's what they're doing here. Let's see what they're writing here. So to handle such cases, so in that situation where we, where we don't want to rely on the buffer, on the GenStage buffer, to handle such cases, we will use two-element tuple as the broadcaster state, where the first element is a queue and the second element is a pending demand. When events arrive and there are no consumers, we will store the event in the queue alongside information about the process that broadcasts the event. Well, this is something we do in our ring buffer, and I prefer the ring buffer solution. When consumers send demand and there are not enough events, that's what we have, we will increase the pending demand. Once we have both data and demand, we acknowledge the process that has sent the event to the broadcaster and finally broadcast the event downstream. We acknowledge the process that has sent the event to the broadcaster. Okay. So, all right, so handle demand is our callback. And what we do here, dispatch events. So when the incoming demand and the pending demand is 0, then we send back the events? No reply. Well, we do send back the events. Here, GenStage reply from event empty. What? Hey, that is not, I don't understand this part. What is happening here? All right. What do you think about the solution? Are you, do you have an idea? Like how because handle demand is that a cast or a call? Handle demand. Because it's no reply, I think it's a cast. Yeah. That would make more sense. So we don't have a blocking call. That wouldn't make sense that, you know, this would be a blocking call. I think it's an async cast. So like the processor sends an event to the GenStage producer, and you know, it's just a cast. So the processor just like casts that event, and then it doesn't care about the response, you know, because it's going to receive it in due time. And that way we can actually kind of we can block the handle demand here until we have enough events, and then we send back all the events. So that's what happens here. So let's say we get an incoming demand of 10 and we don't have a pending demand, so 0. And our queue is also empty. Well, actually, yeah, let's say it's empty. So we do dispatch event, and that so in the beginning we have a demand of 10 and a pending demand of 0, so this would not match. So we would match this one here. It would say queue and then 10 and our events, but our events are empty. Yeah. And then we do queue out, and if it has a value, what is happening here? Yeah, and then basically whenever we have an event, we add it to our internal buffer. Yeah, and then when the demand is 0, then we return the events and we reset our queue to 0. Okay. No reply. Queue demand. But if our queue is empty, we send back the events, but store the demand. Okay. All right, we can try something like that. So whenever we get our handle demand, so we're just gonna set our current state here. I'm just gonna set it to like an empty list. And all right, what is this project about? So what we are doing here is we are basically implementing a data processing pipeline using Broadway and Elixir, where we connect to the BlueSky firehose API. And BlueSky is a social network, just like Twitter, but better. Yeah, and they offer a firehose API where they just send events, you know, all the events that are happening on the platform to your server. So that could be likes, retweets, posts. And our idea is here that we connect to the firehose API, we handle all these events, we store them in a buffer, on the big picture. So we process each post, each new tweet, so to say, and we want to run it through a sentiment analysis, like a machine learning model, you know, using NX. And based on the sentiment of that post, which might be from like -1 to 1, we want to, you know, show a sentiment of the platform over time. So we process every single post, we run it through our sentiment analysis model, and then we receive the -1 to +1 value for the sentiment, like negative to positive, and we just aggregate that information over time, you know, like every minute maybe. Then we have per minute, we have like an average sentiment, and it would be interesting to look at that. I don't know, like, you know, whether it will actually be useful. But ideally we have, you know, like a timeline of the sentiment in the platform. And I mean, ideally you would see that, you know, some events are happening and then all of a sudden everybody tweets about them. And we see, you know, like a negative or positive sentiment at that time. That would be something that would be interesting to see. So the general architecture here is basically that we connect to the firehose API. We use Broadway to process all the events, you know, to fetch the events also from the BlueSky API. The post, because we need to fetch the post content from the API. And then we run it through our model. And the result we store in TimescaleDB, which is a Postgres extension for handling time series data. Yeah, that's the project. Is it? Did that answer your question? Do you think it's a cool project? So What I wanted to do here is basically a do handle demand. So I wanna in a loop kind of just wait until we have enough events and then send all the events back. Yeah, send all the events back. So I'm gonna move all of this into a little helper function that we can call recursively. All right, what's your e-commerce about? And in what way would it be a cool feature? Like the sentiment analysis, I think you mean, or is it the data processing? All right, so in this situation here, we want to kind of so in this situation here, we kind of want to keep track of the pending demand. So we want to see, you know, okay, once the processor comes and asks for 10 events, well, we can't return 10 events, and we kind of want to wait until these 10 events actually are full. A multi-tenant e-commerce app using yeah. From what are you rewriting it? From which language? Are you rewriting it into Elixir? Yeah. So the idea is basically well, first of all, we need to check how many events do we currently. Well, the pending demand is, you know, what we still need, and the demand is the new demand, right? And this is the pending demand. So our total number of events that we need is the new demand plus the pending demand. Now, we will probably not fetch all the events for that, so we kind of need like a counter. So well, we can store all of this. I'll finish WhatsApp e-commerce. Yeah, that's a good idea. WhatsApp business is pretty powerful actually. Oh, from Python. Yeah. To Elixir? Yeah. All right, let me think for a second. So what we have here now is we have a list of events. So basically what we need to do is we need to have a total amount of events. So in here, we can say if the length of the messages are equal to our total demand plus the pending demand, then we actually do a no reply with all with the messages. Well, not this one. Yeah, if all events that we have. So if we, you know, met our demand, so we have 10, they demanded 10, and now we have 10 events in our queue. In this situation, we want to convert all the events to messages, and then we're gonna return an empty event list and also a 0 pending demand. If that is not the case, then we want to call ourselves again with well, new demand 0, because, you know, it doesn't change from this iteration to the next one. And we're gonna put our all events here, and we're gonna, like, we have to calculate how many events are missing still. So that would be now, like, I'm just gonna call this total demand. This is the new demand plus the pending demand. Yeah. Yeah, I can highly recommend Phoenix for writing an API in Elixir. It's super easy. It's really good, and it's gonna scale really nicely as well. Yeah. Can you explain? What would you like me to explain? All right. Let me know whether my math is correct here. So what we're doing basically is we, whenever a demand comes in, we calculate these, like the pending demand and the new demand together. So this might be, you know, like, hey, we need 10 events. So that's our total demand. And then we try to get the total amount of events from the buffer. And, you know, this is where we store them. And then we have a met demand. So we actually know how many events do we currently have in the buffer. So if the met demand is equal to the total demand, that means we have the right amount of events in the... Actually, we should do like a... if it's even bigger, because it... Yeah, we might have some issues here with concurrency. I don't know. But, you know, when we have enough events, basically, to satisfy the demand, then we return them. And if not, then we... store our events in the buffer, and we have our we store how many events we are still missing. Oh, what is an ABI FFI? What is an ABI? A Rust ABI wiki. What's the difference? Interesting. Application binary interface, a public-facing API of an executable that determines how other programs can call into it. Well, I never heard about this. Two binary programmers, often one of these models is a library operating system facility, and the other is a program that is being run by a user. Okay, so you have a library. Or is that like a NIF in Elixir? All right, yeah, the C ABI is the oldest ABI, dating back to C. The C ABI can be used from Rust through the use of extern C. And it describes two main facilities, how data is laid out in memory and how functions are called. Interesting. I did not know this existed. Okay. And you want to write that in Elixir? No, probably not, right? I mean, you could. But how would you explain how the data is laid out in memory? Is that like the data type, the data structure? Interesting. I wrote a Volt ABI in Golang and use it in Python for more core data security. Yeah. I have not coding. Well, maybe you should start coding. It's a pretty cool project. Can you share anything? Can you share the link or something? I would like to have a look at it in Golang. Like, and why would you use it for e-commerce? Like, do you have for core data security? Okay. Like, is that your core service, and then you call it from Python? Interesting project. And what is an FFI? A fatal insomnia. No, I don't think that's it. Fauna and flora. Did I mention it here? Memory management across FFI. Well, what is an FFI? The issue with an FFI is that any memory transferred across boundaries is in essence being managed by two programs at once. Okay, yeah, that makes sense. You give references to the same memory to two different programs. This is a bit of an issue. Rust as a language provides strong memory guarantees, and the point of a clean FFI API is to make it simple as possible to use. Yeah. Once some data has been moved across the FFI boundary, the program that passes the data on no longer retains ownership of the data. This is similar to, yeah, okay. So like you have two systems or two softwares, and one of them is asking, hey, can you give me the reference to that part in the memory, to that variable in the memory? And then the one software actually just passes on the reference, but then in Rust, it loses the ownership of that data. That makes sense. Foreign function interface. Interesting. Today I'm learning. Foreign function interface. It's a mechanism by which a program written in one programming language can call routines or make use of services written or compiled in another one. An FFI is used in contexts where calls are made into binary dynamic link library. Interesting. So yeah, you have a Python interpreter and then you have a shared library. Huh. Yeah, we have that in Elixir too, right? We have the NIF, I guess. Yeah, in Elixir we have Rustler. Cool. Yeah, that is an FFI, I guess. Do they call it FFI? They do call it FFI. Well, they have a tag here, at least. Okay, you have some data like a payment gateway key. All right. Yeah, so in Elixir we use Rustler. I guess that is the FFI. Yeah. All right. Interesting. So yeah, this is away from calling one language from the other. Yeah, in Elixir we have the Rustler and we also have the Ziggler for running Zig code. I never use that. I never use Zig. I don't know. Okay. All right. Let's head back to our producer because I'm curious whether this will work. So let me just print out all this stuff. Okay. All right, so now what we're having here is we have we return 2 events, so our pending demand is 8. And then we probably return 2 more events. So then our demand is 6 and 4 and 2. And then we go down to 0. But then we don't... What happens then? Wait. All right, so you have 2 functions in ABI, encrypt and decrypt. Only my Golang ABI knows how to encrypt and decrypt. Payment keys and Twilio key are very crucial for me. It's a brag-worthy feature as well. Interesting. Okay, so from Python, you call into Golang to encrypt and decrypt stuff. Payment keys and Twilio key are very crucial for me. So you encrypt and decrypt those with the Golang library from Python. Interesting. Why? If I may ask, like, why do you use Golang for that? I think in Python you could also encrypt and decrypt stuff, right? Or is that something you have to share through multiple languages? Yeah, if you can, I don't know. Can you put it on YouTube? I'm not sure whether you can put links on YouTube. Let me check. I mean, if it's on GitHub, you can also just post the GitHub. Yeah. I don't know. Maybe you can just post the GitHub name and then I have a link. And then I can search for it on Google. Yeah. Okay. Something is off when our when we go down to 0. It's not console log. I've been doing too much JavaScript lately. Okay. So our issue here is that we return 3 events, and then our met demand is 3, and our total demand is 1. So in that case, we actually return messages. Oh, and then this becomes negative, I guess. No, this becomes... well, there's a pending demand for 2. Yeah, we return 3. I'm just gonna make this a bit easier. I just want to return exactly the amount of events. No, but then we're gonna lose events. All right, let me have a look at your GitHub. Let's have a look at this one. There we go. In Golang. An ABI built with Rust and Golang. And you have an output here. Okay, so in Golang, I guess this is your module. This is your Go script. Yeah, okay, so you have an encrypt, toString, and you have a decrypt. Okay. And you have an encryption decryption service. Yeah. Well, not bad, not bad. Convert encrypted data to JSON. Okay. Okay, cool. So this is a Go library for encrypting and decrypting, and then you have the same in Rust. And you can do a compute price statistics from a JSON char, from a JSON string. Okay, so you convert it back to JSON, and then you collect the prices and you return it. You calculate the IQR price, which is here. Okay. So yeah, the Python code. All right, so you got the Python code here where you do have a C types, the shared library. Okay, that's how you load the library, and then you can call library.encrypt and decrypt. And then also you have the Rust, I think. Nice. Yeah. And the test in C++. Okay, so this way you can from C++ call Rust code, calculate the prices, and yeah, make sure that the result is not bad. So yeah, you can really move between languages pretty quickly. Yeah, you can also do from C++ here. Not bad. That's your out. All right, not bad, not bad. Looks good. So do you use those for doing quick calculations? For Rust, use CPP. Yeah. Yeah, I saw that here. This one. So why do you drop down to Rust like for these calculations, or is this just more like a test, you know, like a proof of concept for you? And while you answer that, I'm gonna quickly head to the toilet. 1 second. All right, no answer. Sorry. But yeah, it's a cool project. Very nice. If you ever want to do that with Elixir, again, we have the Rustler FFI, and we also have the Ziegler. So this is Rustler, and then we have Ziegler. That makes it very easy to call Zig and Rust code from Elixir. So that's pretty cool. Yeah. Alrighty, cool. Moving back to our Broadway thing. I think we're having some off by one or so issues here. Yeah, it's expensive. Currently it's proof of concept, but when my users add more products as it's multi-tenant e-commerce, in future from multi-tenant I will switch to single shop e-commerce like Amazon, processing 20,000 lists of objects. Oh yeah, I see. Yeah, that you probably want to do in Rust, not in Python. But then you still need to send all that data to Rust, right? Or do you also have a database connection there? Because then, yeah, you can easily connect from Rust to the database, fetch the data, calculate the value of the response, and just send it back. Because if you want to like JSON 20,000 objects, that's going to be just like the transfer is going to be expensive as well. All right, but I think we're getting pretty close here with our producer. I think the problem here is still that we have an off by one or so. Let's see. So when we go here, let's also do this. Let's run this one too. Yeah, okay. So in this situation, we actually have a eventually a pending demand of 2, and we already have 2 events in our in our queue. So in that situation, we would return, well, 0. Well, yeah, so our total demand is not this. It is minus the length of events, right? It is the new demand plus the pending demand minus the length of events we already have. So that way might actually, yeah. Okay, so now we have still a pending demand of 4, and we already have 2 events in our buffer, so we need to return another 2, which we do. Okay, there's 0, so we don't have enough events. Like we return 0 events here, otherwise this would not be 2 because we already have 2 events in the buffer. And that means that our met demand is 2, but the pending demand is 4. So then we should actually do another round here, no? With all the events, and then our total demand minus the met demand. Let's just do it here. Yeah, I have a feeling that also in this situation, we have an issue. Like when we eventually return, let's check that. But I have a feeling that we are not resetting our. Oh yeah, here there you go. Our new demand is -2. We don't want that. So this should actually be an absolute or maximum of 0. Yeah, let's check that one out. Right. Yeah, sounds good. Yeah, I mean, if it's a good feature for you to sell your e-commerce, then that's pretty good. Yeah. If it doesn't slow you down too much with the with just developing your application, right? All right, folks. Yeah, I think there's something off with how we return the demand. So, like in this situation, do we ever return? Do we actually return? So in this situation, we have a met demand. So we have a met demand of 0, and that is, yeah, not bigger than our total amount. But we have, man, I'm just gonna also do another ion spec here. So what we are returning is a length of messages, and our new demand, a pending demand, is met demand minus total demand. Oh, that's cool. Yeah, it's written runs and user for every client's UI. That's good. That's good. If you can resell it multiple times, then it's actually a good investment. Yeah, so our pending here is somehow off. Our pending here is off, and that is, why is that? So our new pending should actually just be 0, right? Because we return enough. Let's just put this to 0, because we actually return enough events. Yeah, but I do want to check return. Length messages. Man, just setting up this producer is already like a whiteboard checking. So then eventually we return 2. Yeah. Which is also interesting because somehow our demand is going down. I think we're doing a mistake here as well. Events. Yeah, something is off here. Maybe let's also just put a time asleep. Just 100 milliseconds sleep so that we don't call. Yeah, there was just a blocking. Yeah, of course, because our producer, it was constantly calling the buffer, and in that time the buffer could actually not add more events to the buffer, so it was blocked. And now it seems to be working. Yeah, that's pretty cool. Look, our data processing app is working, man. This was yeah. I mean, that also makes sense. You know, if you just call the producer, the gen server in a loop, like if you make a looped call to another gen server, you might actually, yeah, block the other gen server from just retrieving more events. Actually, I'm also gonna put this here to like 250 milliseconds instead. So because the buffer, it should have more time to actually handle events, as you can see here now. Because if it has enough time to handle events, then like until our producer actually calls it again, then we can also return bigger batches of events at once, right? Yeah, so we return 5 now because that is also what we have set here as an allowed message per second. We can actually increase this. See how that behaves now. Well, now we're returning here like 5, 7 events, returning 5, 7 events. That's pretty good. That already looks better. Yeah. Well, this is already working. And wait, you said there is a architecture drawing, not here. Types. Source. Output. Is it somewhere in here? The architectural drawing? Nope. No, I can't find it, sorry. All right, so that's already good here. We actually have our pipeline running now. And yeah, we handle the pending demand. So that's good. And we also, like as you can see after a while, actually, we handle, like we have enough events in our buffer. We received enough events in our buffers to always be able to return all the 5 events that they requested. But in this situation, we only have like, yeah, we only return 5 at a time. Why do we only return 5 at a time? Maybe that's because of our rate limiting. I mean, what happens if we just disable this rate limiting? Because we kind of added that rate limiting now with our just sleep timer. Yeah, okay, so now we call the buffer much more often. And then it stops. Yeah, I still think there's an off by 1 issue somewhere, but yeah, the rate limiter was actually pretty okay. I think that is a good thing to have here. Pending 3, new events 3, demand 0, turning 3, yeah. All right, that seems to be working well. My project, yeah. Yeah, so this is our current setup. I mean, it is overcomplicated, but it is overcomplicated because I wanted to use Broadway. You know, I could have just like handled most of the messages in the WebSocket, to be honest, and then have a second WebSocket, second gen server for actually fetching the posts and everything. But the thing is, we wanted to use Broadway here for our application, so that's why it's a little bit more over-engineered maybe. But you know, the advantage of this is now we can extend our pipeline because we now actually fetch the messages. And what I wanted to do, so right here, this is our batching check, like our batching handler. And in here we fetch the posts. So that also means the posts with the content of the actual posts. So the next step would be to do another round of processing because I also want to filter out non-English tweets or posts. And that would be in another round of the handler here, like another processor step. And I could actually like put it into a single processor step where like I do the filtering, but I also do the sentiment analysis. And you know, so if we filter out, then we just like, if it's not an English tweet, we just ignore it. But if it is an English tweet, then we try to run the sentiment analysis on it. So I would say let's go back here. So now we have our processor, which is the decoder. And now the next step would be to do the analysis. And also here we just want to have a concurrency of 1. So, and that is happening here. So in the message, we actually want to add another step. I guess we can do that with message. Put now batcher data. Oh, I think the processor is actually okay. That's probably going to be handled here. So Broadway is probably going to handle the order here, and we just need to do our analysis here. Yeah. And what I'm just gonna do here is print out the message and return the message, just to check that everything's working. And our producer, we can also silence a little. Only one set of processors is allowed for now. Oh, really? No. But what if I want to have multiple processes? Do we have to do another batching? Huh. I can't have multiple levels of processors. Only one set of processors allowed for now. That's not nice. Why is it called processors then? Let's see. Processors. Yeah. I want to log the post in string format. Yeah. That's what I wanted to do in this processing step. But for whatever reason, I can't have multiple processing steps. I thought I could. Let's see the options of, what is this? Start link. So in here we have the options for the processors. Okay, a common misconception is that if your data requires multiple transformations, each with a different concern, then you must have several processes. However, that is not true. Separation of concern is modeled by defining several modules and functions, not processes. Processes are ultimately about moving data around, and you should only do it when necessary. Using processes for code organization purposes would lead to inefficient pipelines. Yeah, right, but yeah, but still, how can I have multiple processes? I mean, do I just... I mean, why do we have the thing here in any case? Oh. I mean, maybe they want us to have multiple batches? Support multiple processes. Well, okay, it's an open ticket, yeah. Yeah, I guess we can also do it in our batcher, but I thought we could have a more complex topology here. Oh, okay, so they say that we should just send it to another Broadway pipeline. And long discussion about the whole thing. So what's the general observations that breaking into steps will often more make things slower than faster. Your code should rather be producer A and then processor B, C, D. Or perhaps D could happen in the batch processor. This is common misconception where folks want to make design steps into logical steps, but moving data around is expensive and you should only do it when necessary. So each layer have multiple internal stages, but even if you discount that, the skeleton of producer, processor, batcher, batch processor is already multi. Okay, so we can still do a batch processor. That's actually what we need. Like we don't need to have another yeah, we don't need to have another processor. I mean, it can also be a batcher or batch processor. But how do we can we move it to another Batcher is the key that defined the batcher. Okay, so we might be able to have multiple batches. Is that true? If I just move it here. And I want to have a batch size of 1. Interesting. Handle batch. And this is receiving messages. Batch info and context. And we're just gonna return the messages as are. Well, our application is running, so that's good. Ah, yeah, we still need to add the batcher here. So on every message, we actually put batcher. And we're gonna forward it to the analysis batcher. I mean, still, that could be a producer, but. But nothing is arriving in the batcher. But that's our. Maybe also we're getting. What are we getting back here? We get posts back. I think we're getting posts back. Yeah, yeah. See, this is the posts here. All right. But then this doesn't do anything. Batcher. It should be forwarded to that batcher, but. Oh, that's a good idea, actually. Elixir forum. Yeah. I will after this live stream. I will just link to this live stream and the previous one and just give an update here. Yeah. But thanks. So that's a great idea. I also wanted to use what I'm learning now about the Broadway implementation, you know, to write another chapter for Run Elixir. Like in Run Elixir, I have a lot of these sections here, and I want to add more stuff to the essentials, and I think Broadway could be an essential thing. Might not be essential, but, you know, nice to know. And I mean, you see that we're running in all these like things where you assume, well, you know, I can have multiple processing steps, so to say, but apparently we can't. So that is stuff or learnings that I would like to put into a very nice overview here. And basically, like in here, I would just add the whole code of the whole Broadway processor, like a whole example, right? Because also our learning here about the producer, where you need to kind of handle the demand on the producer side, that is also something that I wanna add to the to Run Elixir. Actually, let me take a note of that, because otherwise I forget these kind of things. Yeah, Open. Yeah, definitely. Open is going to be in the essentials too. It's one of these libraries that you just use for like 80% of the projects probably. So I'm going to also just have an Open little tutorial there. Broadway, I mean rec, you know, so HTTP requests, cachex for caching, what else? Maybe also a little bit of cloak. Not sure whether you know about cloak. Yeah, that's my idea here. That's what I'm talking about. So on Run Elixir, I would like to have Broadway, Oban, cachex, well, HTTP, so rec, maybe Mint or Finch, I don't know. So some of the HTTP libraries, maybe Cloak, I don't know. You know, Cloak's also interesting. It doesn't get as much use as I would like to, but this is very useful for encrypting data at rest. So when you have any emails or password, well, passwords you always hash anyway, but If you have emails and you want to encrypt them in a database, then you know, Cloak is a really good option because you don't need to handle the encryption decryption. It just does it for you, and that way, you know, you just don't store plain text sensitive information in the database. Oh, that's awesome. Oh, Dave Thomas, yeah. Dave Thomas, he has that with his little Prac Dave. Yeah, right. Oh yeah, programming 1.6. Yeah, that's a good one. Yeah, that's a very good book. Well, thanks for buying my course. I hope you enjoyed it. Did you enjoy it? Did you build something? Do you have a project you wanna show? I can have a look at it. GNOME. Yeah, the GNOME. Wait. Dave Thomas. It's like a coding GNOME. Yeah, I thought he had a course, no? Or was it a book that you read? Discover, learn. Yeah, he has a video course. Elixir for program. Here. No, that's Proglog. Yeah, with a GNOME. Man, it is a little creepy. but it is his sign, kind of. Maybe he identifies with a GNOME. Yeah. Yeah, this one is a fun one. Yeah. All right. So, educational app, nothing open source, but MVP is basis. Yeah, cool. Yeah, great. Well, if you have something, you know, send it to me, or like when I do a live stream, you can also send it to me and then I have a look at it. It's an English Gardens thing. Yeah, I know. They also have them in Germany a lot, like German GNOME. Yeah, we have these like hand painted. Yeah, those, man, I saw them everywhere, and they're quite fun too. But they're kind of creepy, I think. Ah, well, don't worry. This live stream is also a little bit about just exploring other interesting topics, right? So, yeah. All right, but one thing that I have learned now from also just skimming through this Elixir forum thing, where another person asked, you know, how do you do multi-stage pipelines with Broadway, which apparently you don't, or you can use multiple Broadway pipelines. But in our situation, I don't want to do that. I just want to I want to have a single pipeline. So I guess we don't use batches. Like you can't. It's a little like I would love to do circular things here, you know. So from one batcher you either send it back to another processor, or from one processor you send it to a batcher, or from one batcher to the next batcher. That would make it much more. Well, thanks. About streaming, I don't know. Do you enjoy this? Like, because I love this, honestly. I've been doing it previously before, but then it was not project based. It was just reviewing other people's libraries code. And that was cool as well for the people, especially whose code I reviewed. But, you know, it was the first time I looked at the code, so I couldn't really give that much feedback. And I enjoy these projects much more because I can look into different technologies. You know, you see how I use them or how you can use Broadway in this situation. You learn with me. And I love this much more. But the other thing is more like currently I'm also really looking into, you know, how can I grow my audience? And I'm not sure whether live streaming is good for that, you know? So maybe I need to do both. I need to do YouTube videos and live streaming, but that would be too much work. But in general, my idea is just to have a spoken word outlet, so to say. So either it's live streaming or it's podcasting or maybe YouTube videos. But I don't like YouTube videos too much because then I need to compress everything into like 15 minutes. And they're a lot of work to do and edit. So live streaming is much better, I think. But the other thing is I just want to find more people, you know. People should find me more. So I'm not sure whether this is the best outlet. Yeah, but if you enjoy it, great. That's a very positive sign, and that, you know, shows me that this is actually valuable, right? And yeah, valuable to more than myself. Oh yeah, coding yourself. That's great. Actually, what I do sometimes when I have very menial work, I watch Aaron Francis's Mostly Technical podcast. Here, this one, I love it. Like, it's just bantering, like two friends. Actually, like Ian, the co-host, he was sick for a while, but now he's back. But it's just like a fun thing to listen to on the side while you do some work. So yeah, I can understand that. You were watching Korean mukbang as background noise when I saw you were live. What is that? Korean mukbang. Oh, no way. Oh, is that food? Are they eating food? Real mukbang. I'm probably saying this wrong. Mukbang. Interesting. Why? A mukbang is an online audiovisual broadcast in which a host consumes various quantities of food while interacting with the audience. That is that is fun. I should be doing that. But then I would just grow. All right. Well, maybe Elixir streaming is just as interesting and entertaining as eating various quantities of food. Oh my. I learned so many things, yeah. All right, but going back to our processing thing here. So yeah, basically what I understood now is that we can't send the message to another batcher. This is the end, basically, I think. This is what I understood also from the topology thing, where they have like the batcher, where is it? Up here, there. So this is how the pipeline will be represented. Yeah. Process each batch. Yeah, so Elixir streams chess and mukbang. Interesting. Chess. But I mean, you have to watch it, right? Like all these things is something where you actively need to watch it. Like you need to see how the chess moves are going, and Elixir streams, like you'll need to see what I'm coding here, right? Isn't that distracting from your work? I couldn't. I mean, okay, background noise. Maybe that's what you want. Just like somebody talking in the background. I would understand that. Yeah. Processed. Yeah. Yeah. Okay. Well, I guess I'm a little disappointed, to be honest, on Broadway. I thought it was a bit more flexible. I want to have multiple levels. Yeah, like they say, oh, you shouldn't have multiple levels of processors and batches, but I do want that. Well, I mean, it's all right. Like what we can do here is we can actually... Yeah, so what we can do here basically is just fetch the posts and handle them in NX at the same time. But it's not really what I wanted, because what I also wanted is to filter out the posts here based on the language. And then from this batcher, I would return batches, you know, like the messages. And some of them would be failed, some of them would succeed, and then in another batcher, I would actually then process them. Right? I don't know. I like to watch live coding to see how the developer walks through the problems and he solves it. Well, you're seeing that a lot here, so for sure. Like, this is a thing, right? That's what I don't like about YouTube. Because with YouTube, I would need to know all the answers and then record the video. And, you know, so I need to spend all the time of finding the answers and then actually recording the video and explaining the answers and then to, like, post it and everything. And if I live stream, I can do the two things at the same time. Like, I can learn with you, you can ask questions, I can explain things to you. That also helps me understanding it better. And eventually, you know, after like 2 hours of live streaming, I know answers to problems I had, you know the answers, and I have some content that I can share. Yeah, maybe it just makes me feel less bad, a coder, seeing others are also human. Yeah, man. If you want to see people struggle, just look at live streams. Yeah. I mean, yeah, I'm just struggling. All documentation drivers. Yeah, like what you're seeing here is pretty much how I code. I mean, usually I'm not talking that much, obviously, but and that's slowing me down obviously as well. But on the other side, this is my problem solving approach. You know, just like Googling, skimming discussions, skimming the documentation, going back to it over and over again. Yeah. All right. Well, so yeah, uh, uh, uh. And so what apparently we need to do here is to handle, so to fetch the posts and then to also like pass them here to do our sentiment analysis here, although I don't particularly enjoy this. Because then I can't batch. Because now if I wanted to batch, you know, like 10, 15, 20 messages, put them all together, and then run through my model, I can't do the batching here. Like I would always, like if I have, you know, 10 messages here coming in, I fetch the post content for each, and then I realize out of 10, only 2 are English, so I can only use 2 English ones. And then I don't have a batch of 10 English posts, right? I can't ignore the ones that are not English and only batch the ones that are English. So I don't know. Yeah, no worries. I never used really Broadway before, as you can see here. And that's why I'm like, why is it like that? I would like to have another layer. Yeah. What we could do is write a whole nother pipeline for the maybe we do that. Nah, we could though. We could write a whole new pipeline and then for Broadway, and then in that pipeline we only do the filtering here in the processing step, and then the batching would be actually the processing of like the you know, the sentiment analysis. I don't like this. I would love to have everything in one pipeline, because it is one pipeline. It shouldn't be 2 pipelines. But there's really no... Yeah, multiple batching processes with Broadway. It would need to be batching twice. Batching messages. Is there maybe like an after batch like step? Like, is there maybe after the batching, is there another step that we can do? No. Ordering and petitioning. Petition by something. Okay, so that way you can petition messages. This means any message with the same user ID will be handled by the same processor and batch processor. All right. Still not what I want. Well, folks, I think what we will do is to create another Broadway pipeline for the processing of all the posts. Like we have one pipeline for managing the encoded posts. So like we decode them and then we filter them out, and we also fetch their post content. And then another pipeline would be to actually filter out posts that are non-English, and then to batch all the English ones into batches of like 10, 20, and then to handle them there. It's a pity we can't do it in a single top architecture. Yeah, it's really architecture. Internal stages. But apparently it is possible. Look at this. Oh no, that's a supervision tree. Yeah. But This is the architecture of Broadway. So you have a producer, a processor, a batcher, and the batch processor. Well, yeah, that's all we have. So what we can do is the same. We can just internal stages. Yeah, these are the internal stages. The pipeline model. Ah, okay. Okay. Yeah. What do you think? Should we have another Broadway pipeline? So this is the batcher, and in here we, yeah, let's just do that. Let's just make this analysis, and in here we do another Broadway pipeline, and we basically, well, I'm gonna copy paste this stuff. So in here we also have a producer. Yeah. And we're also gonna rate limit that stuff. Oh, we don't need to rate limit this one because we can just analyze them as fast as possible. We have a decoder step and we have a batcher, which is an analysis step. Filter. Yeah. All right. Google constructing effective data processing workflows using Elixir and Broadway. Constructing effective data processing workflows using Elixir and Broadway. This one from Reddit, which is a tweet, a blog post. Yeah. So this guy, he's creating a pipeline too, the basic ingestion pipeline. Okay. Yeah, that's how it looks like. Yeah, no worries. Let's have a look. Okay, he explains the default processor and batcher. That's all good. Well, here we have one root, multiple processes, then we have the batchers, and we have the batch processes. The data. Interesting. So they do have different batches, but they also have a partition. We process batches of these messages. Yeah, so they process them in different batches, but they don't go from batcher back to another batcher. Yeah. We can do a pre-processing step. Handle message. Yeah. And then based on, so in the handle message, in the processor, we can also define which batcher should receive this. Yeah, partitioning. So what I read earlier in the documentation is that partitioning is just basically saying to which batcher. So like I wanna batch all the events related to one user in the same batcher, for example, right? Like maybe they should all be in one long list, and I want to handle them together. So that way, maybe you would need to use Broadway Kafka. Well, that would be connecting to a Kafka stream. So I could push these events now to a Kafka event queue, and then from there I could fetch them with Broadway Kafka. So Broadway Kafka is kind of like an adapter to Kafka. That's about it. Yeah, no, what I need is a multi-stage batching. I need to have another batching step after the last batching step. Oh, we also have a dashboard for that. That's actually pretty cool. Yeah. All right. Now that unfortunately that's not 100% like what I just need, I just need to have another batcher underneath here, but just to be able in the handle batch just to say, hey, this message should no go to that other batcher over there. That's what I tried to do here, right? I thought if I just do message, put batcher, and I do like analysis, then it would actually be sent from one batcher to the next one, but that's not the situation. So I guess what I need to do is, so this here is kind of our, this is our like decoding and fetching pipeline. Right, so all of this, and then underneath here, I need to have another buffer. This is just gonna call the post buffer, and all the batchers they're sending all the events over here, all the posts once they receive them, and then from the post buffer, that's where I start another pipeline. This is where I start. Well, another producer. We can just, this can all be like red. So here I have another producer that fetches from the post buffer, and they fetch only the posts, right? They already like hydrated. Dockyard has a blog post on batching, yeah. But again, I don't think that they do this. They don't allow multi-stage pipelines. So that's the issue. Because ideally, like I would go from this batcher just to another batcher in the same pipeline. And this one would then do the analysis. So I can call this analysis batcher. But that is not possible. I need to start a whole new Broadway pipeline. And for that, I need to have a producer. Actually, in this situation, I could try to rely on the internal buffer that GenStage offers. So I might not need to have a post buffer here. Yeah, I'm gonna give that a try. Because I just want to try different things. Maybe this is also working. So what I want to do is I want to just push it into the producer's buffer, and then from here we have the processor, and this one is gonna do a filtering, just a filtering step, and that one is gonna filter out all the posts that are not English. Yeah, no worries. It's also for me. I'm also learning that, but I just understood now. No, they do not have circular pipelines. It's only producer, processor, batcher, producer, processor, batcher. Yeah. And so what I want to do eventually is another. Wait, this one fetches and this one sends. Yeah, so I want to have another pipeline here. So from my batcher, I'm just going to push the events to another producer. And I have another processor in the new pipeline that simply filters out the non-English posts. And in then, like all the English posts, I'm gonna batch, and I'm gonna batch them, you know, into batches of whatever, 10. I can concatenate them to one long string and just send them to NX, to the model. And that way I can then like control how much I call the model. Because my issue, like what my concern here is that I will send, you know, post one by one to the model, but the model is gonna take, I don't know, half a second to do the analysis. And if I just send 10 posts at the same time to the model, it's still gonna take half a second, but it's gonna process, you know, 10 times more posts. So that way my model doesn't become the bottleneck in the pipeline. And for the average of the sentiment, I don't think it will matter whether I concatenate, you know, up to like 10, maybe 15 posts, or if I do them one by one. Because I guess the average sentiment is what counts. But we need to do some analysis there. Yeah, so this is what I'm quickly gonna set up. I'm just gonna set up here. This is my analysis Broadway pipeline. So in here I have a producer, I have a single processor which filters, and I have an analysis batcher. And we have a handle message callback for the filter. In here it receives a message, and context is not interesting. And basically all we're gonna do, message, Jesus. All we're gonna do is we're gonna do if the message data, and then I'm not sure, the post has a language somewhere. So the record text, that's how we get the text. Yeah. I don't think all of them have a language. Maybe it's optional to add the language. So this guy added an image, another image. Language PT. And that is part of the record, not the value. Wait, I'm just gonna try to find a post that is not super long. This one. So here we see we have the author, and then we have the record. And in the record we have a lungs thing. And it's probably EN for English. So that's what we want. Yeah. So we want to match against record, lungs, and then EN. And if that is, so I'm just going to do that here. So this is a message, data. I'm going to do message data. So in here we match against the record, and then length, and then it should be EN. And in that situation we just gonna we're gonna extract the text. So text here, and we're just gonna do message put data, and we're gonna put the text on there. So that way we can, you know, we only have the text in the last step. Well, and if it doesn't match, then we're gonna call a message failed, and the reason for this is gonna be non-English post. Yeah, so that way we can actually filter and transform our messages already. And then the last step is gonna be the handle batch, and here is the analysis step, and we're gonna receive batches of messages, and this is then where we can run our NX model, where we can, you know, concatenate them and then send them over. So for now I'm just gonna output them and return them. All right, so that is our pipeline, and the other thing that I need to do is to implement the producer. And that's gonna, I'm just gonna do this. And now I wanna, how do we do this? I wanna rely on the buffer. I'm not sure how to do that. Gen stage, producer. So dispatcher, callbacks, demand. Yeah, I want to start a producer with a certain buffer size. Here, buffering. But where is the buffer size? Here. I can do that in the init. All right. So when I do an init, I do producer and then state and then some producer options. And the producer options are demand forward accumulate? No. Where is the buffer size? Here. Producer and produce consumer option. Yeah. Okay. Well, that way we can now our analysis. So this is our analysis producer. And in here, this is where we do the init. So we have a producer. Yeah, we're going to do the same thing again with the handle demand thing. No, I don't think we need to do that. We can just do an empty state. And then in here, we can set our options. And we're going to call like the buffer size. I'm just going to put 1,000. So we keep 1,000 posts in our buffer. And interesting, the buffer keep is also interesting. Here, buffer keep returns whether the first or last entry should be kept on the buffer in case the buffer is exceeded. Defaults to last. I want to keep the first. So that means that like the oldest posts are kept and only the newest ones are discarded. But actually, I'm just going to put this at 10,000. Like we should never run into this situation, I hope. Otherwise, we need to tweak our analysis pipeline. Yeah, and now I'm just going to do the demand buffering. This is what I want. So buffering demand starts the broadcaster. Okay. Oh, yeah, that's a good one. I also want to give this a name. So in this situation, sends an event and returns only after the event is dispatched. Oh, okay, we can define a dispatcher here. So we can define how we dispatch the events, whether it's kind of like a call or a like a pull or a push. Let's look at the demand dispatcher. This dispatcher sends batches to the highest demand. This is a default dispatcher used by GenStage. Okay, so this is what we do with the handle demand callback. Yeah. In order to avoid greedy consumers, it is recommended that all consumers have exactly the same maximum amount. Okay, that's fine. But what we want is the broadcast dispatcher. In this situation, the dispatcher accumulates demand from all consumers before broadcasting events to all of them. This dispatcher guarantees that events are dispatched to all consumers without exceeding the demand of any given consumer. If a producer uses the dispatcher, its subscribers can specify an optional selector function that receives the event and returns a boolean. Okay. All right, interesting. Well, let's just give this a try. Maybe it works out of the box with the Broadway. Where do we have the pages? Wait, where was the buffering here? Gen stage, buffering. This was our example. So in this situation, we don't have a handle demand callback because we have a dispatch event, a broadcast dispatcher, all right? Yeah, and in here we're gonna define our buffer size as well. Okay. Yeah. Yeah, and whenever we receive an event, we actually dispatch immediately, and we don't care about the demand, so this callback is useless. Okay, and sync notify. Well, we're gonna call this differently. We're gonna call this push event. Or put. Push. Push is fine. Not put. Because we actually put this in the buffer, and in here we're not gonna do. I'm just gonna call it a put. Wait, sync. Yeah, okay. Interesting. Alrighty, so, and now this one we're gonna use in our analysis Broadway pipeline. Okay. And what we also need to do is to actually put event. We're gonna call this from our batcher here. So for every event, yeah, for every messages, we're gonna call this producer. So we have to call push event, put event with the message. All right. Yeah. So that way we actually have the post data and we put it into our producer, into the analysis producer. And from there on, our analysis processor and batcher is going to fetch that information. So the last thing we need to do here is to start this as part of our application. So I'm going to put it here. We start, probably get some exceptions. Yeah. Fail to start children, app analysis Broadway, already started. Why is that already started? Did we? I need to rename this one too. Okay. Failed to start child, already started. Hang on. Our name here. This is our name actually. This is the name of the process, so we need to give this a different name than the processor. Okay, one step further. Now, no match of right-hand side. From the producer, we have a fail to start child. And the error here is error shut down, fail to start child. But why? Huh. With our producer. Did we name this correctly? Is that with the init? Maybe the init here is wrong. Let's maybe remove this to see what happens. No. Let's add back our things. All right, folks, are you still watching? Still somebody there? I also gotta wrap it up soon. I have a podcast interview in an hour with my good friend Herman. We're gonna interview for the Elixir Friends podcast. So, hey, you're still there, Philly? Really? You've been here the whole time. It's been 2 hours. Are you listening to me for 2 hours? Gee, that's too much listening, man. Too much listening. And also on Twitter. You are one of my 264 Twitter watchers. Really good ASMR. And Doni, you're still there too. Yeah, I have a soothing voice, right? Yeah, can't wait. Yeah. All right. What are you working on? Stuff for Superbase? Can you share? Is it something, does it have something to do with Broadway? No. Oh, this seems to be a function clause in it. Okay, this seems to be a function clause issue. Failed to runtime error now. Okay. Producer is setting dispatcher to gen state broadcast dispatcher, which is different from dispatcher gen stage demand dispatcher. Okay. Shuffle demands on first dispatch true expected by Broadway. Interesting. But you gotta love the error messages of everything related to Elixir. It's amazing. Here. When true, shuffle the initial demands list, which is constructed on subscription before first dispatch. Okay, we can do that. So we need to define this flag here, set it to true. And apparently that is needed by Broadway. Analysis setting dispatcher to broadcast dispatcher, which is different from dispatcher gen stage demand dispatcher. Okay, so I guess we need to define this one not in the producer, but on the Broadway side. Let's see whether here. I guess in the options. Injected Broadway configuration. Do they dispatcher? No, they don't mention the dispatcher. Yeah. But what we should do here is our options. So we should just set these options in Broadway and not here. Let's see whether this works. No. Producer setting dispatcher to broadcast dispatcher, which is different from dispatcher demand dispatcher, shuffle demands and expected by Broadway. All right. Well, I guess we can't use the broadcast dispatcher with Broadway. What was the name of the podcast? It is Elixir Friends. I'm not sure whether Herman already whether he already announced it. Yeah. Here by Herman. Well, he announced it. No, okay, he thought about starting a podcast called Elixir Friends, where I just have relaxed conversations about work life, etc. with Elixir Friends. And then a lot of people said yes, and I'm gonna be the first guest. Yeah. But I don't think he has an official website for it. I mean, we're gonna do the first episode today, so yeah. Exactly. Thank you, Philippe. Yeah. Well, we can. It seems to be that we can actually use the dispatch. Oh man, I hate this. Educative. Yeah, just don't hide it. What is this gen stage? Yes, I am a human. Let's find out whether we can use the broadcast dispatcher. What is this document pub? Yeah, I guess we can't use the broadcast dispatcher with Broadway. Ah, all right. So we need to implement the demand dispatcher as well. Need to do the whole thing there. Yeah, you know, that's okay. That's okay. Yeah. You know what I'm just gonna do? I'm gonna just copy paste what we have here. Or a handle demand thing. All of it. But the problem there will be that we can't block ourselves while the other event is happening. Yeah. You know what, folks? I'm gonna call it a day here. We already made a big ton of progress. I would say we finished our initial data pipeline. So we actually we get all the data from the firehose API. We put it into our Broadway pipeline. We process it, and we fetch the posts from BlueSky API. So we have that. Now the next step would be to do the analysis part, and that would mean to filter out all the non-English messages, and then to analyze the English messages using NX and the machine learning model. However, yeah, for that we need to set up a second Broadway pipeline because we want to batch the the English messages. We want to batch them so that we can easily, you know, send them to our model in a single string instead of like one by one. The other issue is, yeah, right now just that we need to have this in-between step between our first pipeline and the second pipeline. We need to have another buffer here. I wanted to use a producer that can actually do the buffering for us, something that GenStage actually supports, but Broadway doesn't. So I guess we need to add another step here, like a buffer. I'm just gonna, you know, copy paste the whole thing, like the same setup with a ring buffer and then a producer here. You know, I would just copy paste that and then do the whole thing again, but for another pipeline. Yeah, and all of that just because I can't call another batcher from this one, which is a little, sucks a little bit, but that's okay. I mean, you know, all of this thing is just over-engineered anyway. You know, like for the amount of events we are receiving there, this is like very much over-engineered. We, you know, have like what, 3 posts or so per second, maybe 5. You know, we can easily handle that with like 2 gen servers if we wanted to. But in our situation is we wanted to play around with Broadway, you know, find the problems here, which we very much ran into because we have no circular like batching and processing, for example. That's why we need to set up all the extra pipeline. Yeah. But I'm gonna live stream, I don't know, maybe tomorrow, who knows, I guess. Like, I love this stuff. I love sitting here, I love talking to the camera, like see some people in the chat, old friends actually hanging out with me, that's great. I love doing this. So if you like this too, you know what, let's maybe, well, for next time, I'm gonna set up like a little survey thing on Typeform. And if you want, you can just answer that and say whether you like the stream, what you would like to see more, whatnot. What you would like to see less, you know, how, like, do you like my presentation mode? Would you like me to do stuff differently? Would you like me to explain more stuff? Whatever, just, you know, whatever you want, let me know. You know, you can also put it in the chat. Yeah, but that's gonna be it for today. Yes, good point about the Explorer. That will be interesting eventually. Yeah, you could use Explorer for this Linux ingestion. It's true. Like you can write this with like 2 gen servers, 1 gen server if you wanted to. Probably 2 would be better. But yeah, this is like, but this is, you know, like it's a pipeline you might want to set up if you have really like thousands of events coming in every second, and then you really need to do some processing there and some batching and all. So, but yeah, this is more like a learning exercise. But it's fun. Well, thank you all. Thanks all for hanging out. I'm gonna see you, maybe tomorrow. Otherwise, maybe Monday. I'm gonna be certainly back on Monday, maybe tomorrow, but let's see. And thanks for hanging out. Thanks, Philippe, for coming. And thanks for everybody else in the chat. Subscribe, you know, if you want to be notified. Like, you can follow me on Twitter. You can subscribe to my YouTube here, and then I think you will get a notification. You can subscribe to my Twitch thing, where you also get a notification. I'm also LinkedIn, I guess. I'm streaming to LinkedIn. But if you're on BlueSky, follow me on BlueSky. And I will also post there, you know, that I'm going live and all. So you're going to be notified. All right, folks. Thank you all. And thanks for stopping by. And I will see you at the next one.